In this Technician's Toolbox video, we have a case study submitted by one of our PTS instructors, Matt Donato, concerning a 2001 Ford F-150. The customer complained of the engine runs rough. Customer informs us that they just purchased the vehicle and just want us to smooth out the engine. The odometer shows over 120,000 miles and the vehicle looks pretty good for this mileage. Being a used vehicle, we have no repair history for it. We start the diagnostic process by hooking up our global scan tool and find only P1000. This tells us that any DTCs may have been recently cleared along with any freeze frame and other information. This DTC also indicates that all the monitors have not completed. We take the truck for a test drive and it runs fine right now. Once in overdrive with the torque converter locked, we felt a misfire of some sort. So, where are we so far? We have verified a possible problem, but now we have to identify which cylinder or cylinders are misfiring. Since this is a Ford, we don't have the benefit of a misfire data screen. Back at the shop, we try to brake torque the engine and can only get it to act up very intermittently. With our scan tool, we exit the vehicle-specific setup and go to the Global OBD2 section. We select Mode 6 Data and look at the Misfire section. On this vehicle, we choose TID 51 and SIDS 1 through 8, correlating with the individual cylinders. The data shows us that all the cylinders are passing. Our test drive tells us that one or more of these cylinders are indeed misfiring. We're going to go a step further into Mode 6 Data and look for clues. This data shows that cylinder number 1 has misfires, but they are not high enough to exceed the fail threshold. We scroll through the corresponding data for all the cylinders, and they all have a current value of 0. Just to make sure, we hook up a lab scope to the primary circuits for cylinder number 1. Right now, we are seeing a normal engine pattern. This is not surprising since the problem isn't occurring all the time. After several torque breaks, we are able to capture a misfire. It is definitely an ignition issue, so we install a known good coil and a new spark plug just to cover any possibilities of carbon tracking, fouling, etc. Today seems to be a good day since the misfire turned out to be located on cylinder number 1 and it's easy to access. Being that this truck has lots of miles on it, we decide to go one step further and perform a compression test to make sure that there is no internal engine damage causing this misfire. Since we don't want to spend a lot of time on this, we will do a relative compression test. To do this, we disable the fuel system. In this case, the easiest method was to trip the inertia switch, clamp a high current amp probe around the battery cable. We leave the channel A lead from the previous testing connected to the number 1 coil primary signal and connect a high current probe to channel B. While cranking the engine, we see a nice steady uniform waveform. The relative compression on all 8 cylinders is represented by the increase in the starter current as each piston approaches top dead center. This waveform quickly shows us that this engine is in a relatively good mechanical condition. After replacing the number 1 coil and the spark plug, we take the truck for a final road test to verify our repairs. We make sure that we clear any DTCs that we may have set during our test. We watch the IM readiness monitor status to make sure that most of the monitor is complete and then recheck the Mode 6 data. The Mode 6 data confirms that the truck is repaired. Without Mode 6, we would have had to connect our scope to each cylinder and try to get it to act up, or guess at replacing all 8 coils and hope that the truck was repaired. The Mode 6 data made it a quick, clean, accurate diagnosis and a clean verification. The relative compression test with a scope only took a few minutes and ruled out the base engine as the cause of the misfire and more costly repairs. Most technicians are faced with this scenario and will spend too much time trying to identify the faulty cylinder. Any of these tests can be duplicated using your scan tool and scope the next time you're facing a misfiring Ford. Thanks for watching this Technician's Toolbox video. See you next week.